Hello, everybody. Welcome to TechEd 2007 in Barcelona, and thank you for coming to this talk. They put us into this big room because of the interest, and I really appreciate it. I remember many years ago, I signed up in a search engine to receive notifications when there was something new about API design. And I was receiving maybe 1, 2 emails a week with kind of one new link. Over the years, it became so I receive a new notification every single day, and it contains maybe several links about API design, framework design. So it seems like there's a lot of interest and more interest. So my name is Krzysztof Swalina. I'm a program manager on the .NET Framework team, and I've been working on various .NET Framework teams for 8+ years, designing some APIs in the framework, designing guidelines that people use across the framework. Recently, I started to work on architectural issues like dependency management, compatibility, and so on and so on. And most of the talks, and I wrote a book about API design, I talked about kind of what are the types, what are the members in frameworks, kind of what is the API surface. But there's so much more to framework design. And people started to ask me, hey, just the design process that we follow, it takes us somewhere, but it's not all. You seem to be doing more things with your APIs. So this talk is kind of a broader look at what are all the other processes that affect the design of frameworks, that affect the kind of end result. What is the usability of the framework, how it looks, and so on and so on. So let's get started. What are the prerequisites for the session? Honestly, the only one is having passion for framework design. The session is not very technical. I think it has 300 level. It's a 300 level session, but the reason is I'm going to be talking about some things that usually kind of more advanced developers and architects in organizations care about. It's useful to have some basic understanding of .NET Framework and be able to read simple C# code, but really it's just, I have just a couple of slides showing C# and APIs in the framework. And as I said, expect a mixture of technical and non-technical content. As a note, people ask me, what do I consider framework? Why is this presentation called framework architecture or framework engineering? There's no single definition of what a framework is. My definition is it's a object-oriented reusable library. That's what it is. So objectives and agenda. The main one is to exactly illustrate what are all the other things, sometimes unexpected, that affect the API design or the resulting APIs in frameworks. And I'm going to structure the presentation around 10 guidelines, kind of high-level guidelines of what I consider important things in framework engineering. And also I'm going to show you kind of what are the processes, how do we create frameworks at Microsoft, kind of look at the, what's happening inside Microsoft. And we don't have a single process at Microsoft. In fact, there's no single process in the developer division. So it's kind of my view, my average over what different teams do, what works, what doesn't. None of the processes, I invented them. They are all true processes that somebody uses at Microsoft, but I wouldn't say that any single group uses all of them. So what are the things that influence your APIs? And you can have different categorizations of the processes. I structured them around building organization and how organizational structure affects APIs, planning processes, how they affect APIs, architecture, and that's going to be probably the bulk of the presentation, Then I'm going to talk briefly about design, the design process, how they select what types we need, how they select what members we need, and so on and so on. And then some simple development processes, correct? So we already designed the framework. We have the specs. What do we do to ensure that we actually deliver something of quality? How do we kind of maintain the quality of frameworks over time? And the presentation is divided into those sections. Each of them is marked with icons. So I have an icon. O stands for organization, P for planning, and so on and so on. So let's start with the organization. And many people think, like, what does it mean, organization affecting actually the API shape? How is that possible? But I actually consider it one of the most powerful tools. To give you a quick example is the size of the organization determines whether we're going to have very broad set of APIs or very limited set of APIs. And sometimes we at Microsoft do use things like that to shape the end result. For example, one of the main goals for Silverlight framework was that it had to be small. It had to be downloaded on demand over the internet. And one of the tools that we used to shape the size of the framework was to keep the team very small. So you have probably seen this diagram. It's a very useful diagram. It describes kind of what are the forces, what are the constraints that shape software projects or any projects. And that is the scope, kind of what are the features, how extensive is the API set, what are the parts, feature areas, and so on and so on. Time, which is roughly the schedule, how long it's going to take us to do something, and the cost, like resources, human resources, and so on and so on. And that's a very useful way to think about project management, but I think it's a bit simplistic. It basically assumes that the cost, the resources, are completely uniform. You add one person to the project, you get that much more scope, or you can do it in quicker time. You subtract one person, and it kind of has a very similar effect. Another way to look at it is to say, we have a project management square, correct? And the fourth constraint is the organization. How do we shape the organization? Where are the people who drive various processes? What are they responsible for? What are the decision-making processes? And so on and so on. And we do this all the time. We use organizational structure, kind of improvements in processes. What they are, we don't change the cost, we don't change the people on the team, we don't change time. We say we're going to improve a process. And those are the changes in organization that hopefully affect your projects in a positive way. So what is the organizational structure that we have in the team that develops the .NET framework? And I'm going to talk briefly about kind of some of the decisions that we talked about when we designed the organizational structure. So the .NET framework and Visual Studio, almost everything that ships in the box, is developed by mainly the developer division. And the developer division is divided into people who produce the tools, Visual Studio and languages, and people who produce the libraries, the .NET framework team. And then inside the .NET framework team, there are divisions into kind of the GUI frameworks, application frameworks, and so on and so on. Some libraries in the .NET framework are produced by external partners. So for example, the SQL team produces ADO, .NET APIs, WCF framework is produced by a separate team, and networking types are produced by some Windows teams. So now, what are some of the things that I recently participated in? We have from time to time, discussions about what is the place for the BCL team. And I used to be on the BCL team, so it's very close to kind of my interest. Where is the best place for the BCL team? Should it be with the CLR, kind of closer to CLR, or should it be with let's say, application frameworks. And the trade-off is, if it's with the CLR, BCL team has opportunities to do some, for example, performance optimizations that they would not be able to do otherwise. So the engine, the runtime, has a very intimate knowledge about how, for example, string is structured, and it can optimize performance, how arrays are structured, and so on and so on. That would be much more difficult on a team like application frameworks. On the other hand, there are many features in the application frameworks team that kind of don't take advantage of the kind of culture that is on the BCL team, kind of being able to create APIs that are general purpose, reusable, and so on and so on. So for example, I often give an example that we have several data binding APIs in our application frameworks. If the BCL team was more involved in the design of these APIs, data binding APIs would be more general purpose, and possibly we would have just one. But those are some of the trade-offs. You have to often pick one. You cannot put everybody into the same organization. So this is just a list of some organizational influences that I was thinking about when I was creating the presentation. You probably have in mind many more. But as I mentioned before, the size of the organization influences the simplicity, the scope of the frameworks. Some kind of cultural biases in organizations. Some of them are more customer focused and are better at creating kind of end-to-end scenarios and designing APIs for end-to-end customer scenarios. Some are more technology focused, and they tend to produce kind of architecturally pure APIs, and often it's actually desired for like low-level components in the framework that have to really withstand the test of time. And of course, decision-making processes have huge influence. And I really encourage you, whenever, whatever position you have, whether you are, managing a team or even individual contributor, think about this. What is my organization like? How my APIs are influenced by the organization? And that's kind of the guideline summarizing it. And the picture I chose, a picture of an emergency room, where the trade-off is we want to set up an organization where decisions are made very quickly. They may not be the best decisions. Probably they could take a bit more time making some decisions and arrive at better decisions, but maybe not as quickly. And similar trade-offs need to happen in organizations developing APIs. So let's go to the second section and talk about planning. And I see planning as a way to optimize productivity. So we often kind of say, what are the improvements, small tweaks in our development processes that will improve productivity? And we spend a lot of time thinking about this. But honestly, if you build the wrong API, you build the wrong product, you waste 100% of your resources sometimes, correct? So having the right planning processes, making sure that you build the right things can have huge productivity improvement that is not usually associated with productivity. So what are the kind of two main ways that we design or we plan what we're going to be doing in the next release? And one way is what we call the peanut butter. And that's a design, or that's a planning phase that it's kind of focused on features. We go around the organizations and we say, each team, you prepare the list of features that you want to do in the next release, and then let's talk about this. And what happens is each team says, okay, I've heard from customers, this is missing. I actually know that this other thing is missing, and they produce a feature and kind of improve the existing framework evenly. Correct? They kind of, every team adds something slowly. So the quality of the framework improves very evenly. And peanut butter, the analogy is like you have a sandwich and you spread peanut butter and it's very equally spread, and it improves the bread equally in the whole, everywhere. And the other way that we often approach planning is what I call the skyscrapers. And that's more kind of top-down planning process, where first we select kind of main themes or scenarios that we will be working on in the next release. So to give you an example, in Visual Studio 2007, we said we're going to improve how developers and designers, graphical designers, interact on development project. That was kind of one of the main themes, and we had like 3 or 4 of the themes. And we try to concentrate kind of what are all the features, how do we drive all the organizations to concentrate on this scenario and make a real impact in those areas. And of course, usually you end up with kind of a combination of doing some of the peanut butter and some of the skyscrapers. Again, depending on which part of the framework you're talking about, some core features, like in the CLR, we want to do a bit more peanut butter, correct? We want to keep the engine over time, slowly improve it. In kind of higher level frameworks, I would recommend more of the kind of scenario level planning. So that's the guideline. I said avoid peanut butter. As I said, this is not as strong as do not do it. It's just that in most organizations that I worked in and talked with, there's kind of natural tendency to do the peanut butter. And it takes kind of conscious effort to say, hey, let's concentrate on other scenarios. Let's talk to other teams, correct? One of the problems with the skyscrapers is that it requires cooperation between multiple teams in very large organizations. So now let's switch to architecture. And when people ask me what I think, what is architecture? And you know, in different projects, there is architecture of applications and so on and so on. In the framework space, I think architecture is mainly about ensuring the long-term health of the framework. So feature teams that implement new features in the framework, they kind of concentrate on the next release. They say, you know, in this release, we're going to add, I don't know, long path support or something like that. And they execute, they are really focused on the feature, and that's the right thing for the feature team to do. Architects should think about how will this feature affect the framework in 5 years, and so on and so on. And I think there are 3 main areas of focus, and that is dependency management is really important for the long-term health of the platform, comparability, and kind of duplication or overlap. And I'm going to be talking about these 3 things. So let's start with kind of dependency management. So the guideline is simple. Do manage dependencies in your frameworks. Be very careful about dependencies, as they have a huge influence on the kind of longevity of frameworks and libraries. And the picture shows this kind of ball of twine, and that is what happens if you don't manage dependencies. Sooner or later, you have types depending on other types, these other types depend on other types, and everything depends on everything in the framework, which causes problems like you cannot actually opt out from using a part of the framework, correct? That's not a good thing for evolution. You want to use one part of the framework, you have to take the other one, even if you have no business working with these APIs. So how do we manage dependencies in the framework? We start with what we call componentization. It's basically we select types that belong to components. We define components, let's say, this is the base primitive components. And they contain integers, strings, and so on and so on. This is WinForms. This is ASP.NET. This is event logging. This is performance counters, and so on and so on. So we define those components. And it's a bit of an art and science. But think about types that kind of belong together. They evolve together. They have the same lifespans, and so on and so on. Usually 2 different components, especially in higher level frameworks, are things that are either alternatives or complementary. So we componentize new types and existing types in the frameworks, and then we say, what are the dependencies between them? And we recognize several kinds of dependencies. The kind of most important one is API dependency. API dependency is when you have type A showing in a signature of a member of type B or being a base type of type B. And the sub-bullets kind of show a list of possible API dependencies. And then there's second kind, implementation dependencies. Implementation dependencies are when type A shows in the implementation of type B, or some member of type B. It doesn't have to be in the public API surface. And then implementation dependencies, we manage separately hard dependencies and soft dependencies. Hard dependencies are my method will not run if I don't have the dependency. Soft dependency is kind of optional dependency. And one thing to also keep in mind is if you have a circular dependency between two components, component A depends on component B, B depends on A, or maybe indirectly through C depends on A, for all practical purposes, you end up with a single component. So what we then do is, after we have the list of components and what are the types that belong to each of the components, we basically layer them, which is we structure them into kind of groups that logically are one on top of the other and so on and so on. The most important part of layering is that we distinguish between core framework and kind of higher level framework. Core framework is a set of APIs that we see being kind of universal across all the readers that we are producing. So for example, we have readers like Compact Framework, .NET Framework, and now Silverlight is being developed. And core APIs are the ones that are kind of shared among all the frameworks. And the significance of this is that if you have a higher level component and you depend on the core, the component is portable. You can kind of take at least the source and easily port it to the other framework. And this is .NET Framework, and you may think, how does it apply to what I do? I would say that even small components within the component, they have a very similar structure. Even a small reusable library, you have types that you would consider the core types. They are the types that you think will last for a very long time. And then you have kind of higher level parts of your library that you can imagine being kind of replaced over time. And that's, so you should think about how layering and componentization applies to your feature and kind of try to follow some of the rules that I will be talking about, how you design the core APIs, how you manage core APIs, and so on. So this is just a quick list how we decide which dependencies are okay and which are not. So of course, dependencies going from higher level components to the core are just, people take the dependency, they don't need to ask anybody. Dependencies going up are big no-no. So I was talking about kind of the circular dependency. Allowing a dependency going up basically creates circular dependency. Not always, but sooner or later, it's going to happen, and it's just a big no-no. And then you have dependencies between components within the layer. And here we just manage them, meaning a team that wants to introduce a cross-component dependency within a layer has to come to a review and say, this is the justification. Yes, we know that, for example, we will always have to ship our component with this other component whenever we create new framework, Silverlight, or something like that. So now, how do we design APIs and the frameworks so they can be componentized and layered well versus you can design APIs that kind of are not very good at layering and componentization. And one of the things that we introduced is we think about, we try to divide types in our frameworks into three main groups. Kind of just think about them. Which types are primitives, which types are abstractions, and which types are what I call reusable components. And I'm going to go through all those groups and kind of talk a bit about that. And then once you kind of, it's a conscious thought, which type I'm designing right now, it influences your decisions in the kind of componentization and dependency space. I'm going to talk about this right now in a moment. So primitives. Primitives are just the basic types. It's best for primitives to have what I call the least policy. Policy is basically roughly behavior, but it's a bit more. It's set of design decisions. So whenever you make a design decision, you're like in a room designing with somebody and you talk for a long time, should we do it this way or the other way? There's a big chance that somebody at some point will want to revisit the decision. There's a big chance that the decision that you will make is not the right decision, and so on, which creates problems for, again, the longevity of the API. If in 5 years somebody wants to revisit your decision and you created, string one way, and they want to create string another way, and they introduced another string to your framework, that's a big problem. So we try to design primitives to be quite simple. It's not that they don't have any implementation. You can imagine kind of an extreme primitive in 32, which is just 32 bits on the stack, correct? It has no methods, no behavior, nothing. And that would be kind of taking it to the extreme. But yes, we are very conscious about minimizing the number of decisions and policies in primitive APIs. And that creates stability, correct? Primitives are usually stable. You see that we have a lot of kind of innovation or churn or however you want to call it in higher level parts of the framework. We have, two main client GUI components. We have several XML APIs, yet we have only one string. And it's partially because we recognize the value of having one string. People probably remember the programming in native code with 5 or 6 representations of a string and kind of marshalling between them and so on and so on. That was a lot of pain, wasn't it? So we are conscious that we don't want this to happen in the .NET framework, but at the same time, we actually could not introduce a new string very easily, whereas in the higher level frameworks, there's a bit more churn. And yes, primitives show in all APIs. Any changes to them kind of have a ripple effect. So again, you have to be extremely careful with the design of those. So the second group is abstractions. Abstractions are kind of on the borderline between primitives and libraries. And they are, in fact, the hardest types to design. And we spend the most time designing them. I do API reviews for people creating the .NET framework, and whenever I see some abstraction and they claim that will be the kind of new thing that glues the parts of the framework, I'm kind of a bit skeptical, correct? I have not seen, for example, many abstractions that are successful and have more than, let's say, 3, 4 members. They also need to be extremely simple. Kind of bigger abstractions that are successful, like Stream, are those that have a lot of history in framework and API design, correct? Like people have been doing streams for many, many years, and kind of the design stabilized. Different companies do Stream a bit differently, but kind of the main concept and what Stream should be is well established. New abstractions are extremely difficult to design. I would recommend really keeping them as simple as possible. And they do show in APIs, in other APIs. They are passed around. They have the same kind of ripple effect. When you have changes in abstractions, they are very impactful. But they are, great. They are necessary. They do provide this glue between different parts of the framework. They provide integration between parts of the framework. And then there are those reusable components or reusable libraries. Those are the things that you kind of instantiate the type, you set some properties, you use it, and then you drop it on to the GC. Examples would be something like XML parsing APIs, correct? XML reader and I mean XML document, XPath, and so on and so on. Event log, serial port. And here, in terms of kind of evolution, you need to be very careful about not introducing kind of too many overlapping features, and I'm going to be talking about kind of managing overlap in a moment, but they are relatively easy to evolve. But one kind of thing that you should be careful about, a very common mistake is to kind of mix and match, do a type that is half a primitive, half an abstraction, and half a library. And then you kind of lose the benefit of either. Your primitive is not, the type is not really a primitive. It cannot be used to kind of exchange data over the long lifetime of the framework. It's not really a good abstraction because it's difficult to re-implement it differently because it has too much policy and so on and so on. And it's not actually a great library because you cannot freely replace it over time. So one thing to really be careful about is when you design types, think about which of these kinds your type is and how it's going to affect the evolution of your library. And of course, there's always a mixture of, you have features that have both primitives and the libraries, but we do see differences in parts of the framework and in features. Some are more, some have more kind of components and reusable libraries, and I call it component-oriented design, and some are more kind of primitive-based. And component-oriented design kind of focuses on usability, correct? They have, components have heavy dependencies. They are the Swiss Army knives. They can do many things. But because of the dependencies, as I said, they are very difficult to manage and evolve. Kind of one of the mistakes that we've made is object has a method getType. That's clearly for usability, correct? It gives you a very easy access to the type of each object. It shows in IntelliSense. You say that, you see getType. The problem is now every single instance, every single type in the whole framework has a dependency on reflection. Is reflection a primitive or it's a reusable library, correct? Would it be better to have an alternative design where reflection library can get you a type given an object, an arbitrary object? So I'm going to show an alternative API on the next slide. But sometimes component-oriented design is just great. It provides a lot of usability. It's the Swiss Army knife. It has lots of dependencies, but higher up on the stack is just great. So primitive-oriented design. That's what, some people would say that's just functional programming. We've known that for a very long time, and if you want to call it functional programming, that's great. Some people call it handle-based design, and that's basically a set of reusable routines and set of primitives, and there's clear separation between them, and you kind of pass primitives to the reusable libraries to do operations. And here's an alternative design to the API to get you a type from an object, which is basically a method where you pass the object and you get a type. It doesn't have the dependency problem. You can replace reflection with an alternative reflection in your system, and it doesn't kind of, you don't drag the reflection that hangs off every single object in your system. And just wanted to quick note on a new feature in the C# 3.0 that I thought kind of is a great way to kind of have the cake and eat it too. Meaning you can refactor your APIs to have primitives and libraries, yet have the usability, have the same usability as component-oriented design, meaning you can dot into a method and just get the results. So it's a decimal structure today has two methods, two string, two overloads. One is just a simple one, is culture independent, and the other one has a dependency on the whole kind of culture info and globalization functionality in the .NET framework. And an alternative design would be to separate those two methods. The simple one could be on decimal, or maybe even not. The more complicated one could be moved somewhere else. But because of the extension method syntax, that's this keyword at the bottom of the slide, you can basically use it from languages just like an instance method. You can say d.toString and pass the format. You don't actually have to pass the this pointer anymore. So if you don't know about this feature, I recommend that you take a look. So moving from kind of dependency management to issues around compatibility. That's another thing that architects in our organization, developer division, spend a lot of time on. And it's a very difficult and controversial area. I get a lot of emails from people saying, you have many mistakes in the framework, why don't you fix them? And I say, no, compatibility is very important. And they say, why is it even important? And then you have the other people who say you don't have enough compatibility and so on and so on. So there's a lot of controversy. And I think the kind of moral of this is you need to balance compatibility with advances. But I think people underestimate the value of compatibility. And the way to think about this is that whenever you introduce a new feature, or you change something in the existing framework, you make a breaking change or potentially breaking change, how much are you improving? And how much code, existing code, you're breaking? Correct? There's an enormous body of source code written on the .NET framework right now. And even if you have a change, or we have a change, or in your library, third-party library, you have a change that has a potential of breaking people who built on top of it, it's probably not worth it, or at least it's not a decision that can be taken very lightly. So what are the main things that architects do at Microsoft in terms of compatibility? First is to kind of establish what kinds of compatibility we then want in the release. So for example, when we work on the service pack, we have different compatibility constraints and desires than when we work on a side-by-side release. Recently, the .NET Framework 3.5 release was kind of a mixture of in-place and additions. And again, there are different sets of constraints for the what we call red bits, updates in place, and for the additional features that we added to the framework. Now with Silverlight, we have yet another complexity, and if you develop reusable components on top of kind of .NET technologies, you will have to think about the same issues, like what is my compatibility story between Silverlight and .NET Framework, correct? What is my compatibility story between Compact Framework and .NET Framework, and so on. There are those concepts of backwards compatibility and forward compatibility. Backwards compatibility is I have a component that was built on top of previous version, and I want to run it on top of newer version. Will it run? That's the backwards compatibility. Forward one is I compiled it on a newer version, I want to run it on a previous version. Forward compatibility, for example, is important for service packs. Correct? You want people to be able to develop components on a serviced version of the framework, yet you would like the code to be able to run on a machine that was not serviced. And of course, it's never perfect, it's never binary, kind of black and white, and that's the role of architects, kind of being able to have the overview, what's the importance of compatibility, and provide some guidance. We also now talk about kind of binary compatibility and source compatibility. So within the same framework, .NET framework, we have binary compatibility. You can take component from framework version 3.5 and run it on version 3.0 and run it on version 3.5. We are still kind of closing what's the compatibility story for Silverlight. We know that we will at least have a source compatibility between kind of subset, the core APIs in those two frameworks. We are even working kind of, there's a difference between source compatibility and what I call API compatibility. To give you an example, you could have two different APIs, one returning, for example, iList, and the other one returning array list. And they would be source compatible. You could compile to the API that returns iList and compile the same exact code to the API that returns array list. But that will never be able to be binary compatible. And the reason is when you look at IL of call sites, they basically burn the exact signature of the methods that are called. So a call site would say, I want to call a method A that returns iList. And when the runtime sees a method A that returns array list, the runtime will basically fail. So we have this concept of API compatibility, which means there's no binary compatibility, but at least APIs are exactly the same. There's no kind of these covariant and contravariant changes in APIs. There's just probably some esoteric detail. But again, kind of, what should architects be doing? It's establishing the compatibility bar, deciding for this particular release, this is the bar, these are the things that we care about, kind of being able to balance the advances with compatibility. And now, let's talk quickly about what I mentioned before, kind of trying to be very conscious about duplication overlap. I consider duplication and overlap to be just almost pure evils of framework design, especially overlap, which leads to kind of two features that they can do same thing. Two features can do same thing, yet they are slightly different. And sooner or later, somebody starts using one of the features, and they run into a roadblock, correct? And then they discover there's this other feature that doesn't have this roadblock. But now you have to rewrite your whole program. And it's kind of disruptive. Duplication also creates issues for kind of the whole ecosystem, correct? More data binding infrastructures we have, more complexity we have in like designers, for example, in visual designers, and so on and so on. So it's very important to kind of minimize duplication and overlap. So how do we think about replacing APIs and kind of creating duplication? And we do this from time to time, and I think it does make sense from time to time. But the way I think about this is the new feature that supersedes an old feature needs to be, roughly 10 times better. And that's just kind of, a way to think about this. It's, I don't know how to measure whether a feature is 10 times better or not, but I try to highlight that it cannot be just a small improvement, correct? Small improvements ultimately may have a negative effect on kind of usability of the framework. They improve the lives of 5 people and make it much worse for millions potentially. And an important thing is to think about, if I do the duplication, create a new functionality, what's the migration path, correct? Existing customers who do have code invested in one part of the framework, can they move to the other part of the framework? So let's talk quickly about the design phase. And this is kind of more of the classical talk that I have given several times. But I think that the design phase, kind of selecting what are the types and members, that's what I mean by design, is where the quality of the framework happens. That's what determines the quality of the framework. When people, when I ask people, what do you like about the .NET framework? People usually like two things, which is kind of the design, the usability of the libraries, and GC. correct? I don't have to worry about memory management anymore. So I say quality doesn't happen when you test. It's kind of too late for those two things that people value in the framework. It's during the design phase. So this is the guideline. Every single talk I give, I have to give people this this is my thing, which is I really strongly believe that there's no other way to design APIs than to select a set of scenarios that you want to focus on and write code samples that implement those scenarios. And then maybe start creating other APIs that are required to support the mainline scenarios and kind of finish up the design. But you cannot start with opening a UML case tool or something like that and starting to decide what the types are and entities of the system and so on and so on. Case tools and UML was invented for design of internal implementations. This is API design. It has different constraints because of mainly comparability, where like in internal implementation, you can change internal implementation. What you worry about is not having ripple effect. If you change some part here, not having to change the other part, versus in API design, once you ship, you pretty much cannot change anything. So what's the point of kind of using a technique that was optimized to minimize ripple effect of changes? So this is just an example. You don't have to read the comment or even the APIs, but it's basically a screen capture from an API specification that shows a scenario, and the scenario says, load the grammar from disk that will recognize commands and blah, blah, blah. And then it shows code sample that actually implements how do you load the grammar. And that's for the speech APIs in .NET Framework 3.0. And then we send this specification document to reviewers, and they add comments, and there's kind of interaction. And we first talk about the samples and the scenarios. And then, of course, the team finishes the design. So again, don't have to read anything on this slide. It just shows that we create a very detailed specification, all the types members in a feature area. And again, we send it for the review, and people add comments to the side. That's how we start API design process. And ultimately, we go into kind of full-blown spec, and I'm going to talk briefly about some other things that are included in the specification documents. So the second guideline and important thing is to, I believe, think about simplicity as a feature. So what it means is that when we decide between two features, we say, we can only do feature A or feature B. We cannot do both. Well, let's choose, let's say feature B. And often, we don't do the same with simplicity. We say, we can design feature A, but it will be very complicated. But that's okay. That's the only way to design feature B. And very rarely people look at it. We can design feature B that will be very complicated, or we can not even have feature B, correct? That's the trade-off between introducing more complexity to libraries versus trading off features and saying, we will just not support it. It complicates the framework too much. But there are some simplification techniques. So often we start with a design that we feel is kind of a bit too complicated. And there's this one very common simplification technique, which is let's cut some requirements. Maybe our event log doesn't need to support localization at read time. Correct? It will support localization at write time, but not at read time, which was actually the design in the first version of the framework. It was later added on. That's kind of just cutting requirements, and often people say, it's a very corner case, so let's not do it. But there are some others. So one sometimes missed is basically being able to say, we could design much better API that is already in the framework for something. But we're going to use the existing API, despite the fact that it's not the best API for the scenario, because using existing APIs does not add any more complexity to the system, correct? If I have to read an XML document and it has a specific format, I can either use the generic XML APIs, and it's not going to be as usable, correct? Because it's a specific document, not a generic document. The generic XML APIs have a lot of generic APIs. For my particular scenario, I could design simpler APIs. Maybe it wouldn't recognize XML namespaces. But if I introduced a specific API for my scenario, I would introduce complexity to the framework, correct? Maybe I would have to have some types that complicate my namespace. So the trade-off here is I will use existing APIs. They are not perfect, but at least they don't add additional unnecessary complexity. And then the third simplification technique is kind of adjusting the abstraction level. So maybe I'll use the XML space again as an example. I was working with a team on printing APIs in .NET Framework 3.0, and the initial design was to basically create a bunch of strongly typed APIs to communicate with printer about its capabilities. And there are a lot of printers out there, and each of them has slightly different capabilities, so the API was just completely huge. I mean, it was a namespace with maybe few hundred types to kind of read, can you print double-sided pages, can you staple, and so on and so on. And ultimately, we decided to simplify the API, basically say, hey, we're going to give you an XML document. It's going to describe the capabilities. And in fact, we're going to just reuse the existing XML APIs. It's a bit less usable, but it's relatively corner case scenario to read capabilities of printers. And there was a feeling that it's just not worth adding specific APIs, complicate the system for the benefit that it provides. And that's kind of lowering the abstraction layer, correct? Instead of having high-level specific APIs, we lowered it. It's more general purpose, less usable, but doesn't complicate APIs. Assembly language is the same, correct? There are some processors that have very simple assembly languages. They are very powerful, but relatively simple. They can do everything. Imagine implementing the same thing in a very high-level library, the same thing that an assembly language can do. It is very difficult, and that's why, for example, many languages have inline assembly. So let's move to the next one. The next one is, at some point I wanted to do a talk with Rico Mariani. He's an architect in the developer division, and he mainly worked on performance teams. And I wanted to do a more general talk with him about kind of framework engineering and design and what drives good design. And I asked him, so what would you tell people, like, what's important in design? And those of you who know Rico, his answer is measure, measure, and measure. And he's been telling that when he gives presentations about performance, but then he said, I have the exactly same advice for all design activities that people do in the framework. And then we talked a bit more about this, and his view is that it's actually not the act of measuring that's the most important. It's the act of deciding what do we want to measure, correct? Like, what are the things that are important in the design of the feature that I have? Because we often kind of start the design and we focus on, let's say, usability, and we follow the process that I just said, and we forget about many things that are important, and nobody ever kind of raises visibility of these issues. So the way we do it is basically, we have a specification document, templates that kind of teams designing APIs would use. And the document has those sections that I talked about before, kind of API design, scenarios, the listing of types and members. But The specification template also has sections about kind of qualities of the framework that we would like to design in, design from the kind of get-go. Think about this upfront. So for example, I talk performance goals. It's one of those kind of widely known. And you know, people kind of take the template and they say, okay, I need to develop performance goals. How do I even establish performance goals? Right? Like I'm designing, let's say, configuration system. How do I know what's my performance goal? What should it be? Sometimes it's very obvious. You have competition or you have kind of features that exist and so on and so on. How do you determine or come up with performance goals for something completely new? And one of the things I suggest is basically to come up with the best case. What is the best we could do? So for example, configuration system, what is the best performance of an API that would just read a value with a key from somewhere? It's a database, it's a file from somewhere. What is the best we could do? And then maybe our APIs, configuration APIs, need to do some other things, and they will not be as fast, but at least you have the baseline. You know, kind of, you have some frame of reference, and then you can decide, are we too far from just being able, you know, just opening a file and reading one value, or we are pretty close. In .NET Framework 1.0, I think the configuration system was written on top of XML document APIs. So what happens is a program wants to read one setting in the configuration file. It uses XML document, which loads this whole document, creates objects for every single element in the document, reads one value, and then, you know, as I said, drops the whole tree on the GC. Well, that's definitely not the most performant way to do it. And in fact, the APIs were rewritten in one of the, I think in version 2.0 to use XML reader and writer. And you know, threat modeling or kind of designing security from the get-go is another one of those. And here it's similar, kind of ask the question, what is the best, you know, in performance, what is the best we could do? In security, it is, what is the worst that would happen? That's basically the main value of threat models. I don't know how many of you actually read some books on kind of threat modeling and kind of designing security. I think that the main value from threat modeling is just kind of stopping, not chasing the next feature that we want to add, stopping for a while and thinking, what is the worst that could go with my library? What damage could I do? And just the realization, just stopping and thinking goes a long way. So kind of the last set of processes around framework design, development processes. And I say this is the kind of the last stage. It's the bits that, you know, people either get or don't get. So how do we do development? Kind of as a background, we have the main tree where all the sources for the .NET framework for all those teams that you've seen on the previous organizational diagram, kind of the teams ultimately checking the sources into the main tree. The framework is built from the main tree, but then we have the staging servers, and they contain trees that are basically, I mean, sources that are copies from the main tree where product units do development. And the reason to do it is basically if everybody in a huge organization was checking into the main tree, it would create just too much churn and it causes problems. So we have those staging servers with product unit sources, and they get kind of periodically integrated into the main tree. And then most development at Microsoft actually happens in what we call feature crews. Those are small units within product units, and they actually work on a single feature. And then they would also create a copy of the tree, work in the copy of the tree, do testing, everything. It's kind of like an isolated world, and then integrate into the product unit tree. That's probably a development process that many of you use and know about. And then, what is the guideline? the guideline is, and it's very important, especially for frameworks versus for applications, it's never integrate a feature that is unfinished. Whenever you have a feeling that, this is not the right design, this is not exactly what we want, and the reason for it is that whenever a feature gets checked in to a tree, or checked in kind of means it's available for other people, they start to take dependency on it. Then it kind of discourages you from churning, because maybe you need to fix their code and so on and so on. So we have a lot of processes around ensuring that features are not checked in before they are done. And the process is called a process of quality gates. So we have a set of quality gates that teams have to kind of say, yes, we met the quality gate before they can check in into even the product unit branch. And kind of the definition of a feature that meets the quality gate, we call it feature complete. So what are the things this is the whole list. I'm probably not gonna go through the whole list. I want to leave some time for questions. But some of the quality gates are kind of automatic. People have to run fxcap, a subset of rules in fxcap, and they just have to meet, don't have any violations, and they don't need any kind of manual review. It's all automated process. For those who don't know what fxcap is, I strongly recommend to just search and find out. It's basically a tool that kind of automatically checks your assemblies for design mistakes or compliance with the design guidelines that we use for design of the framework. API review, quality gate, it's a completely manual gate. It's basically a team comes to the review group and presents the APIs, and basically people, experts in various areas in usability and so on, review APIs and say, here's something that you need to fix, or you can check in, and so on. And I think the other items on the list, if you have any questions about any of those, I will be more than happy to talk a bit more during the Q&A. And kind of the last thing that I wanted to talk about is I think that it's extremely important that during the design and development process of your library, you kind of stop from time to time and say, let's not add more features. Let's try to kind of improve the features that we already have, kind of fix some things in place. And I think it's important because it's really useful to have the focus of we are designing new feature, we are adding new feature in kind of regular development processes. And we often tend to kind of neglect the kind of engineering qualities that are not immediately visible. But this kind of bites people later, correct? It's like this chain. It slows down development processes over time and causes problems. So how do we manage this issue? What we do from time to time, we have a separate milestone that we call MQ. And kind of regular milestones start with M0 is basically a planning milestone. We do kind of the scenario planning that I talked before, and so on and so on. And then we start development milestones, which include the design, architecture, and development. So we would have milestone 1, milestone 2, 3, 4, and then we would, let's say, ship. After we ship, we often do quality milestone. So that's kind of before even planning starts from the next version. We said, what are the things, what is the debt that we acquired during the last release? Maybe we shipped something internally that we were not happy about, and it doesn't affect immediately the quality of the framework, but over time it will be impactful to the quality. So let's kind of fix it. And I've seen organizations where there's resistance to it. Like, why would we revisit the decisions? And tinker with the internals, nobody cares about this. I really think it's extremely important. The kind of long-term health of the framework is extremely fragile thing. A lot of frameworks deteriorate over time, or all frameworks deteriorate over time and ultimately die. This is a way to slow it down or stop it. And I think all engineers who design reusable libraries should think about doing quality milestones. So this is just a summary of the guidelines. I'm not going to talk about all of them. You can grab the slides from the TechEd main website. Again, one kind of plug for the guideline of when you design APIs, first design scenarios and then code samples. But this is just kind of an overview for future reference. And a slide with resources. So Framework Design Guidelines, that's a book that I wrote with Brad Abrams. It talks about kind of just the design phase, meaning designing the types and members. I really strongly recommend for all those who both design frameworks and actually use the .NET framework. When I started to write this book, the publisher, when you kind of start up a contract with a publisher, you say, who is this book for? And I said, for people who design libraries. But it was short-sighted. I got a lot of feedback from people who said, I don't design libraries, I use the .NET framework, but the book gives me a way to understand why Microsoft designed the framework one way versus the other, and helps. So I strongly recommend. FXCAP is the tool that I just talked about. The website, there's a link to the website. Please feel free to email me. And I'm really serious. A lot of speakers say, email me, and people kind of sometimes feel afraid. There are so many people in the room. If everybody emails, this guy is going to be reading email for the rest of his life. Ultimately, not many people end up emailing. I really don't mind. I enjoy talking with people about framework design. If that's a common passion, I would appreciate. And there's a link to my blog. I forgot to mention, I gave a 4 hours long talk about framework design guidelines to MSR, Microsoft Research, I think 2 months ago. And it's recorded and it's online. You can find it when you go to the blog and search just for lecture or API lecture, you will find it. So now I'm going to open for Q&A, and I actually have the publisher sent me a box of the books. So come up to the microphone, they are up there, ask a question, and then come over here, you're gonna get a copy. I have 20, and only 10 minutes left. All right, thank you very much, and please, could you? Thank you. Could you please Okay, so the question is, am I planning to write second edition of the book? Yes, so yes, actually I just had a series of talks with the publisher, and I asked them, can I talk to people about the second edition? And they said, once you sign the contract, you can. So we did sign it a week ago or 2 weeks ago. So I will be starting with Brad working on second edition. It will probably ship maybe in a year. It's really writing a book is such a difficult process. I talked with several authors before kind of taking over the project, and they said, it's a lot of satisfaction, but it's a lot of work. I basically did not have weekends for half a year writing the book. I think, the second edition will be some improvements. I'm planning to kind of have information about new framework developments and features, new language features like extension methods, and so on and so on. So hopefully it will not be half a year without weekends, but it's gonna probably take a year. All right?
Can I ask a question? This morning I was at MSF session and the speaker told about continuous integration of the code. And now you said that integration should be completed after the feature complete. Is this for frameworks only or for all the projects?
Yes, yes. So I think the issue is that on very large development projects, I don't believe continuous integration is just possible. So the best way to illustrate it is basically every single checking has some probability of breaking the tree. There's some, we have to correct, there's some, and it can be very small. If you have sufficient number of check-ins, sufficient number of teams working on a project, your main tree will be broken all the time. That's pure statistics, correct? That's how statistics works. I think on small teams, like the feature crew that checks in into a single tree, that's a small team. That's a team often of maybe 15 people. They do continuous integration, correct? That's, up to 15 people, it's no-brainer to do continuous integration. Once you start talking about organizations of thousands, I don't think continuous integration is just practically possible.
Thank you.
All right, thank you. And please come over, pick up the book.
I have a question concerning the format of APIs. We are a company building standard software based on the .NET framework, and we want to offer other companies the possibility to take our software and build add-ons. And we wonder whether we should offer a set of, for instance, web services or something like this, or we should develop, normal .NET assemblies and give this thing away. What do you think about web services as a platform for offering APIs?
Yep. So I think if I had if I analyze the question, there's this common question of, should I just have web service APIs? Or I should provide both web service APIs and kind of some strongly typed .NET proxy that my customers will use. And I honestly don't have kind of a clear-cut guidance like do this or don't do that. But some of the kind of trade-offs I would think about is, is everybody who uses your service using .NET? Correct? If that's true, I would say yes. This is a usability improvement for them, and so on and so on. Is the web service technology something that has description language that allows them to create the proxy very easily? Then maybe the value of shipping a proxy is not as high. They can generate it themselves. They would have source and so on and so on. Versus, maybe you expose a service that is just a simple kind of RESTful service, and then it doesn't have description language. Well, then maybe yes, maybe you should develop kind of manually a strongly typed proxy and save the time for customers. So as I said, I don't think there's clear, I have a lot of insight here. I am involved in some design of APIs, kind of web service APIs at Microsoft in the kind of live group. But honestly, most of the API guidelines that we created, I was trying to be very cautious. It's not like I come up with guidelines on the spot and without kind of testing them. I can have kind of, we would have like what are the trade-offs? Let's analyze the trade-offs. But most of the guidelines that are in the book are tested, correct? We first kind of came up with the trade-offs, tried to use them in the design, and then said this works, this doesn't work. And I think for the web space, we are still in the phase, we kind of talk and analyze the trade-offs. We don't yet know what the answer is. I think still kind of the web services space is quite immature in comparison to kind of object-oriented frameworks, and it will be some time before we know kind of what is the way to design web service APIs.
Thank you.
Hi. Do you think there's an overlap between API design and domain-specific languages?
Could you please repeat the question? When I come up here, I actually don't hear the question because the microphone is here. Sorry.
Okay. Do you think there's an overlap between API design and domain-specific languages?
I see. Yes, I think there is. In fact, we often, and you can see framework libraries as kind of domain-specific languages. And we often start with thinking, how can we design something in the framework first? And again, test it. Say, yes, this is a useful thing. And then maybe add it to the language. So, we are doing some thinking around the concurrency effort. I don't know how many people went to Joe Duffy's talk on concurrency. He was talking about PFX, parallel framework. It's a great framework. It's kind of, you can see it as a domain-specific language. And we are continuously thinking, like, should some concepts from libraries like that end up in languages, correct, in future languages? Should we pull them in? So I think there's a lot of tie between languages and frameworks. One way kind of to illustrate it is, I know that for many kind of new developers, it's really not clear what is the framework, what is the language. Like, is int a language or is int a framework? So I think there's a lot of tie. Frameworks go together with the language. Even on kind of multiple language runtimes as CLR, there are influences, correct? It's a kind of runtime that is designed for kind of object-oriented or functional languages. There's a big interaction between those two.
Do you think that parts of the entlib will ever make it into the framework?
The enterprise library?
Yeah.
Yes, so from the beginning of the enterprise library, when we talked with the team, there was always kind of the plan that they will be developing kind of cutting edge or things that are missing from the framework that they get feedback from customers. They will be developing those libraries. And we will look at them and we'll say these things actually add enough value to justify the additional complexity that I was talking about, and we pull them into the framework. We do it all the time. Sometimes it's not visible because we change things. As we pull things into the .NET framework, we often modify them slightly. But I was involved, I actually was the designer for the tracing APIs in .NET Framework 2.0. And it was something that I talked quite often with the enterprise library team about their previous kind of implementation of tracing functionality, and many concepts were pulled into the .NET Framework APIs. So this process is happening all the time.
Thank you.
I have a small question. Can I have a book? No, that was just a joke. I actually have a question.
I will accept this question, but don't ask this, every question can be asked only once.
I wonder if you have tips when to stop developing a framework, because I was involved developing a framework once back in 2000, and we end up building .NET framework in C++.
Yes. So I think this relates to what I was talking about, kind of duplication and overlap, and making sure that the feature that you add adds enough value to offset the kind of complexity and having to teach your organization about new APIs. So one way I talk about this is that there's this concept of addition through subtraction, correct? Sometimes having less is actually more. And that's just a balance. I'm not saying, there are many things in the framework that will just not work for everybody, correct? Framework is a general purpose reusable library. When you have very advanced scenarios, you should be developing your own APIs. But you have to be very, very careful. It's a kind of slippery slope, correct? We start developing, we don't like this control, okay, we add new control. Oh, we don't like data binding, let's add data binding, and so on and so on. And soon you realize that you live in your own kind of world. You don't integrate with, Microsoft design tools. Documentation is structured differently, and so on and so on. So it's a trade-off. It's a trade-off between kind of doing your own complexity and being on your own at some point versus using something that may not be perfect for you. I also designed the collection libraries in .NET, and for a very long time we struggled with, should we be adding linked lists to the framework? I don't know how many of you remember that we didn't have linked lists for a very long time, and ultimately we added it to the framework. But I participated in the design process, and I'm not 100% sure whether linked list is something that makes sense in reusable frameworks. The reason is that it's kind of the issue of diminishing returns. You start with simple data structure like array list, and it's just the right data structure for 80% of scenarios. Then you add a new one, let's say, hash table. And the next 10% of scenarios are covered with hash table. And then it's diminishing returns. And the problem with linked lists is that there are it's not just one data structure. There are actually hundreds of ways of implementing the linked list, not only kind of API surface, but even kind of internal implementation. Do you store them in array and you optimize for locality of reference, or you have links and so on and so on? It's just hundreds different ways of implementing linked list. And if we add one to the framework, how many people will be happy with it, correct? We're gonna kind of diminishing return. We're gonna grab, 5 more people will be happy with it, and we're gonna complicate the system collections namespace for millions. Is it worth it? So those are kind of frameworks whenever you design something for a broad set of people.
Okay, thank you. I hope I find some good tips in your book.
Yeah, I think we are being kicked out from the room, so I will be more than happy to kind of answer more questions on the side. Please, and I have still a book of books. So I really, again, appreciate you coming here and all interesting questions, and please fill in the feedback form. I would appreciate it. Thank you very much.